In 5G networks, the 3GPP has made some major changes to how things are set up compared to older LTE systems. First off, they've separated the control plane, CP, which handles network management tasks, and the user plane, UP, which deals with data traffic, into separate and distinct parts. In older LTE systems, a lot of these functions were bundled together in a few key nodes. But in 5G, they're spread out for better performance and direct connectivity between nodes. Another cool feature is network slicing, managed by something called NSSF. This allows the network to be divided into smaller, specialized slices that can be customized for specific needs, whether it's for different types of devices, services, or even specific customers. This makes it easier to offer services that need quick response times or more reliability. 5G also introduces a new function called Application Function, AF, which lets the network support cutting-edge services like artificial intelligence and vehicle-to-everything, V2X communications, not just regular telecom services. Lastly, AUSF has been added just to make sure that devices and network can mutually and securely authenticate to each other, even when they're using non-3GPP technologies to connect. So, in simple terms, 5G is more modular, flexible, and capable of supporting a wide range of modern services and needs. Let's describe the role of each 5G network function in the following section.
The Access Management Function, AMF, in 5G networks is like the control center for managing connections and security. It's the point where the network talks to mobile devices through the N2 interface and handles secure messages via the N1 interface. The AMF takes care of registering devices on the network, making sure they can connect and move around within the network area without losing service. It also plays a role in legal tracking when needed and routes different types of messages, like session or text messages, to the right places. On the security side, it checks if a device should be allowed to connect to the network and keeps that connection secure. It also manages location services to meet legal requirements. So, in a nutshell, the AMF is crucial for making sure everything runs smoothly and securely on a 5G network. The Session Management Function, SMF, in 5G networks handles a lot of tasks related to setting up, changing, and ending data sessions, kind of like setting up and managing conversations between devices and the network. It helps create and maintain the tunnel that your data travels through between different network points, UPF and AN node. The SMF also deals with assigning and managing IP addresses for devices, and it works with both DHCPv4 and DHCPv6 for this. It also controls how and where data should flow within the network, essentially telling the UPF how to route traffic. User plane function. UPF is another key network element that will be explained shortly. If you're using services that require special rules like certain apps or websites, the SMF talks to policy control functions to manage this. On the legal side, it helps with lawful intercepts, collecting necessary data. It's also involved in billing by gathering charging data. So the SMF has a big role in making sure that data gets where it needs to go, securely and efficiently, while also taking care of legal and billing aspects. The User Plane function, UPF, in 5G networks serves as a critical junction for handling data traffic and enforcing policies. First, it acts as an anchor point for mobility, meaning it helps your device stay connected when you're moving between different types of networks, like from 4G to 5G. It also serves as a connection point to external data networks, making sure your data gets where it needs to go. UPF is responsible for routing and forwarding packets of data, and it can even differentiate between types of data to decide how best to route them. UPF also inspects packets to identify the kind of application they're associated with, like whether data is coming from a video streaming service or a web browser. It enforces various rules and policies on the data plane, such as controlling the flow of traffic or redirecting it when needed. It helps with legal data collection, reports on traffic usage, and manages quality of service, QoS, by setting data speeds and ensuring priority handling for specific services. It also checks the incoming data to make sure it aligns with the quality guidelines and marks packets for proper routing at the transport level. Additionally, UPF buffers data coming from the network to the user and can trigger notifications for downlink data. Lastly, it manages end markers to signal the end of a data session to the originating network node. In simple terms, UPF is like a traffic cop and a quality inspector rolled into one, ensuring that your data travels efficiently and securely through the network. The Network Repository Function, NRF, in 5G networks is Service Repository Database within the 5G core. It's responsible for discovering 5G network function based on services, capability, not based on domain name. It discovers newly added functions dynamically. NRF is important in case you have different slices of 5G with different capabilities. Examples of cases of NF discovery, SMF discovery by the AMF. The mean parameters used here are the NSSAI for network slice identification and data network name DNN. General, we have multiple DNN in a 5G network, for example, DNN dedicated for mobile traffic, DNN dedicated for IoT, DNN dedicated for enterprise customers, DNN for URLC customers, etc. The User Data Management UDM function in a 5G network is a secure database that stores and manages user and network information. This includes subscription details, security credentials, and other data needed to authenticate and authorize both users and network elements. When you connect a device to a 5G network, the UDM checks this information to make sure you're allowed to use the services you're trying to access. The node responsible on the authentication and security check is the Authentication Server function AUSF, which is implemented separately from the UDM. CHF stands for Charging Function, as the name indicates, is used for user charging based on time, throughput, packets, locations, etc. The PCF Policy Control Function, AT, was called previously in 4G as PCRF. PCF is not a simple continuity of PCRF. The PCF came to enforce rules and policy based on specific service based on data collected from all nodes in 5G differently from the PCRF, thanks to the SBA service-based architecture, which makes all 5G nodes interconnected through Open REST APIs interfaces. Also, 5G PCF, contrary to 4G PCRF, is able to control non-session-related traffic such registered and not connected user equipments.